in this one we are trying to merge intervals. So if we are trying to merge all overlapping intervals. So return an array of non-overlapping intervals that cover all these intervals in the input. So in this case, if we take a look, so 1, 3, and 2, 6, they overlap, so we just merge them together. So now it's from 1 to 6. And in this one, 8, 10, so 6 up to here, it doesn't overlap, and it doesn't overlap, so we return the same. Well, yeah, let's solve this problem. So first thing first, the way I'm going to approach this problem, I'll be sorting this given intervals and go from there. Arrays, let's sort intervals using lambda. And let me define a helper method which will help me to see if it overlaps or not. It's given two intervals, so let's say A, B, and for overlapping, the way it's going to be is I'll be getting the maximum of the first value of these two intervals, and on the right one I'm getting the minimum of the second values of given interval, and then I'm returning if left is smaller than the right. So in this case, if this is true, that means it overlaps. If this is false, that means it doesn't overlap. So let's get our A. That is going to be intervals 0. So in this case, let's take care of our intervals when length equals to 0, because this is for length 1. And when it is 0, there's going to be out of bound. So in this case, we can just take care of this edge case. So perfect. So now let's go over our loop of this. We can actually do index based, because like we took care of the 0. Now we're starting from 1 until the intervals length plus plus. Now let's get our second interval, which is coming from intervals I. What we are going to do, we will check is overlap our method, pass our A and B. So if it overlaps, so we need to have a way to store all these values. So let me define I. So this is going to be my merged array deck. And then I can add this A to here initially. So merge. I can add last. So this is my kind of like linked list. So I'm adding it to last. And then from here, if it overlaps, then from merge, I'm removing last, because I added last, I removed last. Because this overlapped, we need to add a new version of it. So new int array, and then what will be the first value of it, because like this is an overlap, it's going to be the minimum of this values in here. So I can say math minimum of a0 by b0, and what will be the next value? It's maximum of these two, so max a1 with b1. Perfect. So once we have this, we can actually update our value. So because like we have our a, now a should be equals to this newly created value that we have. So you can actually put it in a new merged interval. So here now it's updated to merged interval. So else, if it doesn't overlap, then we will just add our given b and update a to b. And in the end, we'll just returning our merged. However, this is an deck, so we need to do to array and new integer. So this is going to be a merged size of it. Perfect. So let's run our code. Output is 1445. So, oh, this was not merged. Expected is 15. So we are considering this to be 1, because like this is not overlapping, but it's on the edge. This can be combined, so all we need to do is just like equal to here. Perfect. Nice. So earlier we saw that even if it was not overlapping per se, but it was with continuously, then we just merge them together. And what is the time complexity? So time complexity in here, we are using arrays.sort, and this is O of n times log of n. And here we're also using some space, and then of course default built-in sort here, the team sort. It is of n. So overall time complexity is O of n log n, and then space complexity is O of n.